Okay, so what do we want for an answer? Minutes. What do we start with? So it's up to you on what you want to start with. The first thing I heard was hours. We don't officially have hours, but we do have a unit with hours in it. Okay, so hours is a measurement of time. So what I can do is say, whoops, let's say hour. Why do I want the hour on top? Not quite. What is minutes a measurement of? Time. Where's time in our answer? In the numerator or on top. What is hours a measure of? Time. Where should it show up in our answer? In the numerator or on top. So I can leave my hours up on top. Okay. What do I have hours related to in my question? Miles. Okay. What number shows up in front of hours? 1. What number shows up in front of miles? 17. Okay. So now we can go through and start our conversion. We got an interesting dilemma that comes out of this. We can go through and convert our hours over into minutes, but even if we do that, would we have our answer? No, because we still have those miles in there. Okay, so where do you guys want to jump to now? Keep with the time or deal with the miles? Okay, I heard someone say deal with the miles, so we'll start with that. Where should miles show up in my next? Why does it need to show up in the numerator? It needs to cancel the unit in the previous conversion. Okay, so those units need to cancel. What information do I have about the miles? I know I have 15.7 miles, and this is where people are going to tend. Is it this? Yeah, 15.7. This is where people are going to panic. What do I put in the denominator? This is just looking at miles. Do I have a relationship between miles and minutes? No, so I can't bring minutes in. Do I have a relationship between miles and hours? Is it 15.7 miles an hour? No. My relationship is 17 miles an hour. There's that relationship. It's already been used. What was that? Somebody said it. What do I put? Okay, I don't know who said it. I thought someone said it up here. Put a 1. The value that we've got is 15.7 miles. Okay, so the number that I would need to include down there had better not change the 15.7. The unit that I put down there had better not change miles, because the number I'm using is 15.7, and the unit I'm using is miles. Am I allowed to divide by 1? Yeah, because what does it do? Nothing. Okay, it may look weird, but it doesn't matter. I'm not changing the number, I'm not changing the units, so don't worry about them. Leave them as a 1. What units are we at now? Go ahead. Someone said it. We're at hours. What units do we want? Minutes. Do those equal each other? No, so what do we need to do? Hours. Oh, wow, that wasn't too bad. And minutes. I can actually do some more space on that one. Do you have a conversion between hours and minutes? Yes. What is that conversion? 60 minutes is equal to 1 hour. What are my units now? I'm in units of just minutes. What units do I want for my answer? Minutes. Do I have to do any more conversions? Nope. I'm now done. I can go ahead and punch into my calculator. Again, how I would run this would be 15.7 times 60, and I would get an answer, and I would divide that by 17. What was 15.7 times 60? 942? Oh, you said 942? Was that the number going? Oh, okay. I heard 109. I was like, this something does not sound right. Divided by our 17. Was it 942 with any numbers, or is it just 942? Oh, that's nice. Now I can divide by 17, and I get 55 point, does it come out at just 55.4 flat? Okay, that's enough. And officially, minutes. Okay. Because this is a show your work question, I'm probably not going to care about it. You can probably look at that number and match it to the multiple choice. Hopefully that matches. Yeah? No? Yeah? There you go. There's your answer. Okay, does that make sense?
What would the Sig Figs mean?
So, Sig Figs, right? First question I would kind of put to that is if you look at your answer choices, does Sig Figs matter? Actually, it looks like it does. Because we have one answer that's 55.4 and we have one answer that's 55. So Sig Figs is actually being asked for in our answer. So we'd have to look at this carefully and decide how many Sig Figs. How many Sig Figs? I heard 3. Why do you say 3?
Because 15.7 miles.
15.7 miles. I agree, that has 3 Sig Figs.
But
But
what about the 17?
it is not, it's not an infinite value. It's a measurement. It's a measurement of your speed. That has 2 Sig Figs. Your answer needs to be reported to 2 Sig Figs, 55 minutes. It's not a bad commute. It's only an hour. It's a little bit longer than that. A little slower than 17 miles an hour. Sure. Yes. B, not A. What's that? Okay. Other questions? Yes.
On this one, or can I ask about another one?
Are we good on this one? Yes. Anything you want?
This density of the platinum nugget problem.
Can you spin it around for me? Of platinum nugget, we actually get the details. Platinum nugget in pounds per liter, given that our mass is 22.4.50 grams and our volume is 10.0 centimeters cubed. Right? So, what do we want as an answer? Pounds per liter. Pounds is a measure of?
Wait. Math.
Thank you.
Sorry. I'm not.
Mass.
My words
That's
today.
close enough. Liters is a measure of volume. Ooh. Watch out for the podium. Do we have a mass? What is our mass? 224.5. Where should that show up in my calculation? Talk about that in a little bit. Where should it show up? Numerator. When writing down your work, should you include the 0? Yes, but probably not for the reason that you're thinking. It is a significant digit, and you will likely forget that that 0 is there as a significant digit, as we saw already when I solved this problem sort of before. Okay, so it's more helpful to show that 0 so that you know it's there when you run through your calculation. Do we have a measure of the volume? Yeah. So what can we do? Put it in the denominator. Do we have to do it in that exact same spot? No. I could break this out into 2 separate calculations. This gets back to our weird, ugly calculation. 1, 10.0 centimeters cubed. Right? Completely identical calculation. I'm definitely going to run out of space on this one. Right? Everybody okay with that? Yeah. Do our units match? Do grams equal pounds? No. Do centimeters cubed equal liters? No. So we've got to convert both of those units. What unit do you want to look at first?
Centimeters.
I heard grams first. Sorry. Centimeters was louder, but grams was first. So we want pounds in our numerator because I just said pounds. I said nothing about grams. Why do I want pounds in the numerator? That's where it shows up in my answer, in the numerator. Now we can look at the grams. Where do I want the grams? In the denominator, because I want that unit to cancel. Okay. Do I know the conversion between grams and pounds? Yeses and nos are good with that. I would say no, I don't know, and I would immediately panic and say, please God, put it on the front of the exam.
That's exactly what I was thinking.
And we look at the front of the exam. What number shows up in front of pounds? 1. What number shows up in front of grams? There we go. Our grams cancel. We're now in units of pounds. Cool. One fell swoop. We've switched over our masses. What about our volumes?
Well, it's 1 to 1 centimeters to centimeters squared to milliliters.
Okay, so we do run into a slight issue here with this conversion. We want centimeters cubed to show up in the numerator so that it can cancel. And ideally, we have liters down below. And this would again be those kind of panic moment. Please God, is it on the front of the exam?
It's wrong.
It's not on the front of the exam. Okay? Because that conversion is not directly given. Okay, in general, it's not a common conversion. Is it?
Yeah.
Really?
Yeah, 1,000 centimeters cubed.
You got to be kidding me. Where'd it go?
Oh, yeah.
Yeah.
Oh, what do you know? Okay, well, shoot, look at that. I gave it to you. So, what number shows up in front of liters? What number shows up in front of centimeters cubed? 1,000. What happens with our units? Where's my units? Centimeters cubed, cancel. And we end up with our units as pounds per liter. There's our answer. I can't believe I could put that on the exam. Okay, so I'm not going to worry about taking it off. I got too many other things to deal with to worry about removing stuff from the exam. Why was I suggesting or kind of hinting at the fact that you guys should know this one already? This is a strict metric conversion. You are responsible officially for your metric conversions. Okay? The simple one is not centimeters cubed to liters. That one's not the easy one. But as was listed earlier, we have the conversion of centimeters cubed to milliliters. 1 centimeter cubed is 1 milliliter. We also have the conversion of milliliters to liters. What does milli mean? 10 to the negative 3. You could use both those conversions to ultimately go through and get the exact same answer. Should I show that?
Now you get it.
Okay. We'll accept that then. Does that answer your question well enough?
Yeah.
Okay. Other questions?
Can we go over some of the stuff in the periodic table? Just like some.
I'm not sure what stuff we can try. So this is going to be meaningless to record. A lot of information stashed in here in a variety of ways that we could tackle this. What we're concerned about primarily in this case is what is the mass of zinc in that dime. Okay? So if we're going to look at these as percentages, I kind of appreciate it if you guys are going to chat outside. What we're going to do is take a look at the percentages. Well, what was our percent? What did a percent mean? Particularly a percent, say, of tin. What does that mean? Both of you are kind of right. We're looking at the mass of tin. Should not be using that capital N. Out of the total mass. The total mass is our mass of our dime. What does that mean out of 100? Well, there's another way that we could look at that. We could say, what was the mass of our dime being 100 grams, what would the mass of tin be? Okay? Either way, we're going to get at the exact same kind of percentage out of this. So we've got information about the percent of tin. Okay? The other thing that you typically do would be multiply by 100% to get your percentile value. But I don't really care about the mass of tin, I want the mass of zinc. Okay, well, do we have any information about the mass of zinc if I'm given the information of the mass of tin? What makes up a dime? Zinc and tin. Is it made up of anything else? Okay, theoretically, no, otherwise it would be an awful question. Okay, so it's just made up of zinc and tin. So if it is 80% tin, what is its percent zinc? It is 20% zinc. How did you do that? Simple math, nice way to phrase it. What we're saying is that the percent, oops, let's erase that for a second. Our percent of zinc plus our percent of tin must equal 100%. Otherwise, something is really weird. Do we know the percent of tin? Yeah, we know it's 80%. We don't know the mass or the percent of zinc, so what we can do is now solve for our percent of zinc, and we get 20%. Right? This again comes back to now our mass over the total mass. Okay? So that would be using this guy up here. Except now instead of it being tin, we'll make it zinc. Well, I know that 20% equals the mass of my zinc divided by the mass of my dime times 100%, or times 100. Do I know the mass of zinc? No, that's what I'm solving for, so no, I don't know that. Right? Do I know the mass of the dime?
Yeah.
It's 2.568 grams. Can I solve for the mass of zinc now?
Yes.
Yeah. So what I can go through and do is divide both sides by the 100, multiply both sides by 2.568, and I will get the mass of zinc equaling 0.2 times 2.568 grams. Punch it in the calculator, I get my answer. Do we have to solve it this way? No. We could have solved for the mass of tin. Because we're given the percent of tin, we don't have to calculate the the percent of zinc. So we could have solved for the mass of tin. Once we have the mass of tin, though, could we figure out the mass of zinc?
Yeah.
How?
Subtract it from the mass.
Subtract it from the total mass. We'll get the exact same answer. Okay? So percent calculations, particularly if there's only two species, we can solve them a variety of ways. All of them are equally valid. It depends on what you see to get through it easier. Make sure you track your units carefully and what species you're looking at. You notice this one might have been a bit trickier, probably unintentionally, because I use zinc and tin, and those first symbols are very, very similar. Now, you may not think so, but I think so when I was writing it. Okay, S versus Z. Okay, so just kind of watch out for that. Other questions?
You do the extra credit.
Ugh, okay. Can I steal yours?
Give us the answer.
What do you mean I gave you the answer to it?
No, I said if only you did. That'd be nice.
Oh.
That would be really cool.
What were you saying over there, someone? Oh, fascinating. You read the directions. What'd you find out? You know the answer to what you're trying to solve. That said, it also says you're only graded for your work, so. Okay. But if you've done the work right, you should be able to punch it into the calculator and see that your answer came out correct. So that could theoretically help you out.
What if we do the work wrong?
Wrong, you'd still lose points. Well,
we
it
get
depends
some
on your work. Sorry, can I do that? Where is it? Depending on how wrong your work was, you could get partial credit. So we have volume equals 0.645. We have to figure out one edge of a piece of foil, and we're given the volume. And actually, I made it more difficult because I said figure out the thickness in micrometers. So this question becomes challenging because of that silly unit conversion. So based on some people that I've already seen their work on, the good first place to start would be looking at a picture. we've got some object with some unknown thickness, and we know some of those dimensions. Right? And we know that if we take a volume, our volume is going to be multiplying all of those out. I don't know why I did all the x's, but it's our length times our width times our height. What's the unit on our volume? Millimeters cubed. What's our unit on our length? Millimeters. What's our unit on our width? Millimeters. And our desired unit for our height? Micrometers. Okay, so one way to go through and solve this is to try and convert all of your millimeters into micrometers before you go through and run this. That is probably the hardest way to approach this question. Instead, what you should go through and do is solve for your thickness, which I keep switching variables on you, in units of millimeters. Once it's in units of millimeters, you can then convert it to micrometers. Now you don't have to worry about that stupid cubing effect, and everything can come out nice and cleanly. So to go through and solve for our thickness in terms of millimeters, we can divide both sides by our length and our width. Our thickness, our volume was 0.645 millimeters cubed, divided by our length. I don't remember what our numbers were exactly, but not that big of a deal. And 12.5 millimeters. One of our millimeters cancels and it becomes millimeters squared on top. The other millimeter comes through and it becomes just 1. When we punch into our calculator, we will get, for units, millimeters. Now that we have the millimeter unit, now we can deal with our overall conversion of our millimeters to micrometers. Do I know a conversion between micrometers and millimeters? Whoops, and that would be the wrong way to put the units in. That's what happens when you go fast. Millimeters on the bottom, micrometers on top. Do I have that conversion? Could check to see if it's on the front. I don't think it is, but we just should have micrometers on the front. What do we have micrometers related to? Should have it related to meters. So I can convert my millimeters into meters. What does milli mean? 10 to the negative 3. Both of you were correct. 10 to the negative 3 is the more appropriate answer, but you're not wrong. Meters go on the bottom, micrometers go on top. Our conversion there, 10 to the negative 6 meters is 1 micrometer. And I now have my answer. You can go through, like I said, from the very, very beginning of this problem and solve for your answer in micrometers from the outset. But that requires converting millimeters cubed into micrometers cubed. That also requires converting millimeters into micrometers, and that millimeters into micrometers. You end up repeating that calculation so many times that more than likely you will do that calculation wrong and screw up your answer. If we solve it in millimeters first and then convert across, it's cleaner. You really only do your micrometer millimeter conversion once as opposed to 5 times. Right? So the method shown here is a lot faster. And we are done.